Hello everyone, you are welcome to Mathematics Tour. This is IGCSE Mathematics paper 2-2 written in October 2023. I have previously uploaded the variant 2-1. You can check my channel. The links to download the past paper solved in this video and the PDF solution are available in the description section below this video and also available in the comment section. If you are seeing this channel for the first time or you are yet to subscribe to my channel, please kindly click on the subscribe button as your subscription means a lot to me. Also, comment, like and share this video. Let's jump into the first question. Question 1. Write 24.07839 correct to 2 decimal places. So if you count from here, 1 and 2, so 8 is your decider. It tells you to round up and it becomes 1. 1 added to 7 is 8, so we are going to have 24.08. so correct to the nearest 10. Okay, so this is 10 here, that's 20. Then 4 is not up to half of a 10, then we're going to round off, so that would be 0, so it should be 20 to the nearest 10. Then 2, write down the number that is 9 greater than minus 23, so that would be minus 23 add 9, so that would be equals to negative 14. So negative 14 is the number that is 9 greater than negative 23. So we have negative 14 here. Then number 3, v equals to u plus 80. Find the value of v when u equals to 30, a equals to negative 2, and t is equals to 7. So here we have v to be equals to 30 plus open bracket minus 2 into 7. So v will be equals to 30. If you expand this, we're going to have negative 14. So this and this combine together to become negative. We have v to be equals to 30 subtract 14, and v will be equals to 16. So question 4, change 62,000 millimeters into kilometers. If you use the acronym, King Henry died by drinking chocolate milk. So this is the base where you have the meters, liters, and grams. So this is millimeters and this is kilometers. So if you want to convert 62,000 millimeters to kilometers, that means you have to move towards this direction. 1, 2, 3, 4, 5, and 6. So that is 6 times. So let's write down 62,000. So let's move from this spot. 1, 2, 3, 4, 5, and 6. So that means the decimal point will be here. So you need to fill this with a 0. So the final answer will be 0.062, okay, kilometers. So you don't need to repeat the remaining zeros as they do not mean anything. Okay, so let's go to the next question. That will be question 5. We are asked to find the value of x. So to get the value of x, you can find this angle first. So this will be 50 because these two angles are vertically opposite angles, and you can only see them in x shape, x like this, and this. Okay, so then if you look at the whole of this angle here, 50 and x and 114, they are alternate angles, as you can see them in letter Z when you take it from here. Okay, let's trace it out. If you take it from here, then downward, then this side, that is the letter Z. So we can say that, okay, let's scroll down a little bit. So we can say that x plus 50 is equals to 114. Then x equals to 114 subtract 50 then x is equals to 64 degrees. So you have 64 degrees here. So let's go to the next question. So that will be question 6a. Explain why 111 is not a prime number. So 111 is not a prime number because it has more than two factors, or it has another factors aside 1 and itself. So you can say it is not a prime number, so because it has other factors aside 1 and itself. Okay, you can write it here, 1 and itself. Okay, so all prime numbers have just two factors. Okay, it will be 1 and itself, but in this case it has other factors which are 3 and 37. Okay, so for that reason it is not a prime number. Find a prime number between 110 and 120. So this would be 113. Okay, so some students could pick 119, so you need to be very careful. 119 is not a prime number because it is divisible by 7 and 17 respectively. So you need to check very well before you pick the number. Okay, so let's go to the next question. That will be question 7. Find the bearing of Q from P. So this is point Q. Okay, so we want to find the bearing of Q from P. So it will be, if you like, you can divide this like this. Okay, so the bearing will be from the north up to this line. Okay, so if you extend this very well, you see that this angle and this angle, they are found in letter Z. So they are alternate angles. So this will be 39 degrees. Okay, so to get this angle here, so you can do 270. That's 270 subtract 39. So that will be 270 subtract 39 degrees. Okay, so that will give you 231 degrees. So the bearing of Q from P is 231 degrees. So let's go to the next question. Without using a calculator, work out this. So you can say 3018 minus 1034. Okay, so you can subtract the whole numbers. That will be 30 minus 1 whole. Then you can now find the LCM of 8 and 4, which is 8. 8 divided by 8, that is 1. 1 times 1, you have 1. Then minus 8 divided by 4, you have 2. 2 times 3, you have 6. Then 30 minus 1 whole, that will be 2 whole. Then 1 minus 6. So some may say it is impossible, but you can still do it. Okay, let me show you different ways you can do this. You can say 1 minus 6, that will be minus 5. Okay, then over 8. Then you need to write this as an improper fraction. So by multiplying 8 by 2, that will be 16. Okay, then 16 minus 5, that will be 11. So you have 11 over 8. Okay, then which is now 1 whole 3 over 8. Okay, so this is one way of doing it. Okay, or from here, so or from 3 minus 1 minus 6 over 8. So from here you need to borrow 1 from here. Okay, let's do this. You can say 3 minus 1, that is 2 whole, then 1 minus 6 over 8. Okay, so before you can subtract this, you borrow 1 from these 2 whole. So that will be 1 whole. Then the one you borrowed will be equivalent to your denominator. That will be 8. 8 add 1, that will be 9. So you have 9 minus 6 out of 8. So that will be 1 whole 3 out of 8. So So this is what you get, okay? And you can still use another method you think it is easy for you. So you can make use of common denominators and you still get the same answer. So let's go to the next question. That will be question 9. So write 90 as a product of its prime factors. So you can just use downward division like this. Then you have 2, so this will be 45. So 3 can go again, this will be 15. 3 can go again, this will be 5, and finally 5 can go, that will be 1. So that means 90 will be equals to 2 by 3 by 3 by 5. So which you can write as 2 by 3 to the power of 2 by 5. So you have 2 by 3 to the power of 2 by 5, okay? So number 10, expand and simplify this. So 2 by t, that will be 2t, then plus 2w plus 3w minus 3t. Then this will be 2t if you rearrange minus 3t plus 2w plus 3w. So this will give you minus t plus 5w. So which is same thing as 5w minus t. So that will be our final answer, 5w minus t. So the next one will be question 11. We have these two similar shapes, okay? So find the value of h. So to get the value of h is very simple. So we have 6.3 as the ITS. So you can just find the ratio of corresponding sides. So this will be 6.3 over 9. That is, this side over this side will be equals to h over 5. You take the corresponding ratio at the second shape. So if you cross multiply, you get 9h to be equals to 6.3 times 5. And if you divide both sides by 9, so you have the value of h to be equals to 6.3 times 5 divided by 9. Okay, so and that will give you 3.5 centimeters. So h equals to 3.5 centimeters. So part B, the area of the smaller shape is 16 centimeters squared. Calculate the area of the larger shape. So you can say the area of the smaller shape, let's denote it by this, is equals to 16 centimeters squared. So we want to get the area of the larger shape, that is LS, excuse me. Okay, so to be equals to what? We want to find this. Okay, so if you go back to the shapes, okay, you can take any two corresponding sides. So I can take this and this, or the height against the height, okay? But I'll just take this and this. So I'll say a side from the smaller shape, okay? So let's say that is a side from the smaller shape, that is SSS. So this will be equals to 5, okay? That is this side, okay? Then we'll take a side from the larger shape. So that is SLS, that will be equals to 9. So to get the area, so it will be area of the smaller shape over area of the larger shape equals to square of a side of the smaller shape like this over square of a side of the larger shape like this. So let's key in the values. So this will be, this implies this 16 over area of the larger shape we want to get equals to 5 squared over 9 squared. So this will be 16 over area of the larger shape to be equals to 25 over 81. Then you can cross multiply. So area of the larger shape will be equals to 81 times 16 over 25. So if you take your calculator and do this, you get 51.84. So area of the larger shape is equals to 51.84. So let's write this 51.84. So you have 51.84 centimeter squared. So let's go to the next question. That will be question 12. The diagram shows a speed time graph for 16 seconds of a car journey. Find the deceleration of the car in the final 4 seconds. Okay, so the final 4 seconds will be here, and the deceleration is this. So we have the speed to be 10. Okay, so the formula will be 10 divided by 4. Okay, because acceleration and deceleration mean the same thing. It just be speed over the time. Okay, so you can say the deceleration is equals to the speed, which is 10 over the time. Okay, that will be 4, and this will give us 2.5. That's meter per second squared. So you have 2.5 here. So part B, find the total distance traveled during the 16 seconds. Okay, so this will be the area covered by this shape. Okay, so the total distance covered will be the area of this shape. Okay, and you have two options. You can find the area of trapezium, or you find the area of this rectangle. Then you find the area of this triangle and you add them together. So for me, I'll just make use of the area of a trapezium. So from here to here will be 12. Okay, already. So from here to here will be 16. So I can say A is equals to 12, and then B will be equals to 16. So the height is 10. So we have all the parameters. So you can say that the area of a trapezium is equals to A plus B multiplied by H, everything over 2. Okay, so A will be equals to, can substitute the values. We have 12 plus 16, okay, times 10, okay, so divided by 2. So when you add this together, this will be 28, then 2 here 1, 2 here 5. So you have 28 multiplied by 5. Okay, so this will give you 140. So that will be the total distance covered. Okay, 140 meters. So let's go to the next question. So this will be question 13. Question 13a, find the value of P. So here we can use multiplication of indices to combine these two together. So that will be 3 to the power of 3p add 2p, then to be equals to 3 to the power of 6. Then we can now add this together. This will be 3 to the power of 5p to be equals to 3 to the power of 6. Okay, so this will cancel this. We are left with 5p to be equals to 6, and the value of p equals to 6 over 5, which is the same thing as 1 whole 1 out of 5. So 1 whole 1 out of 5. So part B, you have this. You can write 32 in base 2 if you want. Okay, so that you can have the powers and you expand by multiplying the powers by 1 out of 5. So that is, you have 2 to the power of 5, that is 32. Then x to the power of 10 into 1 to the power of 5. So you can now expand by multiplying the powers by 1 over 5. So this will be 2 to the power of 5 times 1 over 5. Then x to the power of 10 times 1 over 5. So this will cancel this. We are left with 2 to the power of 1, which is 2. Then x to the power of 2, as 5 goes in 10 twice. So the final answer here is 2x to the power of 2. So let's go to the next question. So that will be question 14. So y equals to 2w squared minus x. So rearrange the formula to make w the subject of the formula. So you have y plus x to be equals to w squared. Then you can write it as 2w squared equals to y plus x. Okay, then you can have w squared to be equals to y plus x, everything over 2 when you divide both sides by 2. And finally, w equals to square root of y plus x over 2. Okay, so that will be the final answer. So square root of y plus x, or x plus y over 2. So let's go to the next question, question 15a. On the Venn diagram, shade the region P union Q complement. The simple trick you can use to do this is to firstly shade the whole of P, then you shade any other region that is not in Q. So you can go to my channel. I made series of videos regarding this on sets, theory, and Venn diagram. So this was well explained there. Okay, so let's shade the first one. So let's shade the whole of P. So that is the meaning of P here. So you shade this like this, like this, like this, like this. So you shade the whole of P. So be careful not to omit this side, okay, because it is part of B, okay, this particular intersection. So you shade the whole of P. Then the next thing is to shade outside Q but inside the Venn diagram. So outside P, outside Q but inside the Venn diagram will be P itself that we have already shaded. Aside P, we also have this side, okay, so you need to shade the whole of this, okay, so that would be P union Q complement. So that is how to go about this. So part B, the number of elements in the set is 20. So we have A union B complement to be 1. Okay, that is outside here will be 1. Okay, so the number of A equals to 12, number of B equals to 10. So complete the Venn diagram. So for this one, what you need to do is to add all the numbers together. You see that you have 12 add 10, that will be 22 plus 1, 23. So subtract 20 from 23, that will be 3. So the intersection here is 3. Then from 12 subtract 3, you get 9. And from 10 subtract 3, you get 7. So this is how you can complete this, and everything add up to 20. So find the 16. Find the lowest common multiple, that's LCM of 12x squared and 8. Find the lowest common multiple of 12x to the power of 8 and 8x to the power of 12. Okay, so there are a lot of methods you can use to find the LCM. I think I made some videos in that regard, so you can check my YouTube channel again. Okay, so one of the ways you can get the LCM of 12 and 8 is to divide 12 and 8, okay, simultaneously. So you have 2 goes in 12, 6 here, 4, 2 can go in 6, 3 and 2 here. Then 2 can go, so it cannot go in 3, so you repeat 3, and 2 goes in 2 once. Finally 3 can go, you have 1 here, 1 here. So you have the LCM to be 2 times 2, 4, 4 times 2, 8, 8 times 3, that will be 24. That is one way. Another way, okay, is to multiply the 12 by 8, okay, and divide by the highest number that can go in 12 and 8, which is 4. So this will still give you 24, okay, because 4 here 1, 4 in 12 3, okay. Or another way is to write 12 in index form. So 12 will be equals to, okay, let's come down a little bit. Okay, so all you say, or 12 is equals to 4 times 3, which is 2 to the power of 2 times 3. Then 8 is equals to 2 to the power of 3. Okay, so then you compare the two numbers, and you select the number with the highest power. Okay, so the LCM, okay, will be equals to, we have 2 to the power of 2, 2 to the power of 3, so we select 2 to the power of 3. Here we have 3 to the power of 1, and we can say here we have 3 to the power of 0 because it means 1. Okay, so we select this. Okay, that is times 3. So we can see the LCM is still 24 because you still have 8 times 3, 24. So the same way, you can get the LCM of x to the power of 8 and x to the power of 12. Okay, you just select the bigger one, which is this. Okay, so that means the LCM will be 24x to the power of 12. Okay, so let's go to the next question. Okay, that will be question 17. A, B, and C are points on a circle, center O. Angle OBA equals to 28 degrees. Find angle ACB. So this angle here will be 28 degrees because this and these are equal. They are both radii. And you also know that AOB, from here, AOB will be equals to 180 minus the sum of these two angles. That will be 28 add 28, so which is equals to 124 degrees. That will be the value of angle AOB. And we also know that angle ACB will be equals to angle AOB divided by 2 because they are both angles at center and angle at circumference respectively. So this will give us 62 degrees. So that's the value of angle ACB. Angle ACB will be 62 degrees. Let's go to part B. P, Q, and R are points on the circle. TU is a tangent to the circle at P. Angle TPR equals to 47 degrees and angle PRQ equals 52 degrees. Find angle RPQ. So angle RQP equals to 47 degrees. So angle RPQ equals to 47 degrees. That's angles in alternate segments. So if this is 47 degrees, then this will be equals to 47 degrees. Okay, so we can now find RPQ now. So RPQ will be equals to 180 degrees minus the sum of 52 and 47. Okay, so that is how you can get RPQ. Sum of angles in a triangle, okay, is 180 degrees. Then this will give us 180 subtract 99, and the final answer will be 81 degrees. So let's go to the next question. That will be so we can put 81 degrees here. So the next question will be question 18. A solid cylinder has radius 5 centimeters and height 8 centimeters. Calculate the total surface area of the cylinder. So the radius is given as 5 centimeters. Then the height is equals to 8 centimeters. So if you like, you can quickly sketch. So you can just draw a cylinder like this if you want. Then you have another one here. Okay. Then you can put the top here like this. Then this one like this. And do the same thing here. Okay, and just have a sketch of that. So this will be the height, and it is 8 centimeters, and this will be the radius, that will be 5. So this will also be the radius, 5 centimeters here. So to get the total surface area, it will be the total surface area denoted by TSA, because to the curved surface area, that will be CSA plus 2 times area of the base area, that will be area of a circle. So the base area, VA. Okay, so the curved surface area of a cylinder is 2 pi RH, then plus 2, the base area is area of a circle, that's pi r squared. Okay, so we can now okay, let's expand this. This will give us 2 pi r h plus 2 pi r squared. So we can factor out 2 pi r. So we have 2 pi r into h plus r. So we can now substitute the values. We have 2 times 3.14 times the radius 5 into 8 plus 5. Okay, so you can do this directly. Okay, this will give you if you multiply these three together, you get 31.4 into 8 add 5, that will be 13. So the final answer will be 408.2. Okay, so 19a, find the nth term of the sequence. So the nth term of the sequence, let's see, this is minus 3, minus 3, minus 3. So the term to term rule is subtract 3. Okay, so you can say the nth term is minus 3n. Okay, so if you try to generate some terms with this nth term, you see that we're going to have, we'll get minus 3. Let's write it up, minus 3. So the next one will give us minus 6, minus 9, minus 12, and so on and so forth. So if you compare this sequence with this sequence, okay, so you see that they are not the same, okay, because the first term should be 11. We got negative 3. So what can we add to negative 3 to make it 11? So that will be plus 14. So if you add 14 to minus 3n, so that will give us each of these terms. So let's confirm, when n is equals to 2, we should get 8. So let's test it with this. So minus 2 times, minus 3 times 2, that will be negative 6. Minus 6 plus 14, that will be 8. So this is the nth term, minus 3n plus 14. So let's scroll down. Here you have times 5, times 5, times 5, times 5. So this is the, or you can say divided by 5. So if you are moving from left to the right, it will be times 5. Or if you are moving from right to left, so that will be divided by 5. So the common ratio is 5. Okay, so this is an exponential sequence. Okay, so what you can do here is to multiply. Okay, so we can say the nth term, okay, is equals to 5 to the power of n. So that's the common ratio to the power of n. So if you test this now, 5 to the power of n, so let's test it to get, let's use it to get some terms. So it will give us 5, when n is 1, 5 to the power of 1. When n is 2, 5 to the power of 2. When n is 3, 5 to the power of 3, and so on and so forth. Okay, so if you compare this sequence with this sequence, you see that they're not the same. So this is the first term, and this is what this is the first term rather, and this is what we got here. Okay, so what can we do to 5 to make it 1? So you have to divide by 5. So that's what we need to do. So let's test it now. When n is 1, you have 5 to the power of 1, which is 5. 5 divided by 5, you get 1. When n is 2, you get 5 to the power of 2, that's 25. Divided by 5, we have this. When n is 3, you get 5 to the power of 3, which is 125. When you divide by 5, you have this. Okay, so this is the nth term, but you can write this better by applying division law of indices. This is 5 to the power of 1, so that will be 5 to the power of n minus 1. Okay, so you can write 5 to the power of n minus 1 as the nth term. So let's go to the next question. So that will be question 20. The area of a rectangle is 55.2 centimeters squared, correct to 1 decimal place. The length of the rectangle is 9 centimeters, correct to the nearest centimeters. Calculate the upper bound of the width of the rectangle. So we know that area of a rectangle equals to length times width. Okay, so to get the width now, length times width. So to get the width now, so the width will be equals to the area over the length. So the upper bound of the width, the upper bound, okay, of the width, so will be equals to upper bound, okay, upper bound of the area, okay, divided by lower bound of the length. So that's what you need to do. So now let's get the upper bound. Okay, for the area, so we can get the upper and the lower bounds. So upper and lower bounds of the area. Of course, that will be 55.2 plus something, and the lower bound will be 55.2 minus something. Okay, so to get that something, you need to take note of the angle degree of accuracy. So this is corrected to one decimal place, that is tenth. So tenth means 1 out of 10. So which is same thing as 0.01 when you divide it by 2. Which is the same thing as 0.1. So when you divide by 2, so that will be 0.05. So that is what we need to add and subtract respectively. So plus 0.05 minus 0.05. So the upper bound will be 55.25 and the lower bound will be 55.15. So let's write this very well. 55.15. Okay, so for the length, you can do the same thing. The length, the upper and the lower bound will be 9 minus 9 add something, 9 minus something. Okay, so the degree of accuracy is to the nearest centimeter, which is 1. So 1 divided by 2 will be 0.5. Okay, so that means this will be 0.5 minus 0.5 here. So this will give us 9.5 and this will give us 8.5. Okay, so we cannot get the upper bound of the width by substituting the values here. So let's scroll down a little bit. Okay, so this will be equals to the upper bound of the area, that is 55.25 divided by the lower bound of the it's correct, the lower bound of the length, so that will be 8.5. Okay, and if you do this, you'll get 6.5 centimeters. So the upper bound of the width is 6.5 centimeters. So 21, the line y equals to x plus 1 intersects the curve y equals to x squared plus x minus 3 at 2 points. Find the coordinates of the 2 points. So let's equate them. This is equals to y, this is equals to y is equals to x plus 1, y equals to d. So we can say that x plus 1 is equals to x squared plus x minus 3. So if you rearrange, so this will give us x squared plus x minus 3 minus 1 equals to 0. So this will give us x squared. So this will cancel this. Minus 4 to be equals to 0. We have x squared to be equals to 4. So x equals to plus or minus 2. Okay, so when x equals to 2, so y will be equals to x plus 1. That will be 2 plus 1, which is equals to 3. So that means one point will be 2, 3. Okay, so when x equals to negative 2, okay, so we're going to have y to be equals to minus 2 plus 1. So y will be equals to minus 1. So that point will be minus 2, minus 1. Okay, so this will be the second point. So the coordinates will be minus 2, minus 1. Then we're going to have 2, 3. So that will be the coordinate of the 2 points. So let's go to the next question. That will be question 22. X is inversely proportional to the square root of w. So that is, we have x is directly proportional, is inversely proportional to the square root of w. You have this. So we can write this as x to be equals to k over root w. Then when x equals to 16, x equals to 3. So we can call this equation 1. That means we have 3 equals to k over root 16. So we have 3 equals to k over 4. That implies that k is equals to 12. So if you substitute k equals to 12 into equation 1, okay, so that means we can have x equals to 12 over square root of w. Then find x in terms of w. So this will be the answer. X will be equals to 12 over square root of w. So let's go to the next question. So this is question 23. So some adults record their reaction times. The table shows the results. Okay, so on a histogram, the height of the block for the range interval is 7.5 centimeters. Calculate the height of the block for this interval. So what we need to take note is that when you have a histogram like this, okay, so you have this, so the height is the frequency density. So that is what you need to take note, and that is what we're going to use here. Okay, so for this class we'll get the frequency density, let's say fd1, and this one frequency density fd2. Okay, so the formula for frequency density equals to frequency over the class size. So that means here you can say the frequency density 1 will be equals to the frequency over the class size. So that will be the frequency here is 18 over the class size equals to 6 minus 0. So that will be 6 and it will be 3. Then the second one, frequency density 2 will be equals to the frequency is 16 and the class size equals to 10 minus 6. That will be 4. So this will give us 4. Okay, then we can now say that, okay, the ratio, that is for the first one, the frequency density 1 is equals to h1, the height 1. In this case, the height 1, I can write it here, h1 is equals to 7.5, and h2 is what we want to find now. So over fd2, so over what, h2. So if you key in the values here, so you're going to have 3 out of 4 equals to 7.5 over h2. That means if you cross multiply, h2 will be equals to 4 times 7.5 divided by 3. So if you do this, h2 should be equals to 10 centimeters. So that will be the value of h2. So let's write down. So the height will be equals to 10 centimeters. Okay, centimeter is already there. Okay, so let's go to the next question. That will be question 24. Simplify this. So what you can do here, let's rearrange. We have ax minus x minus 2a plus 2, everything over a squared minus 1. So we can factor out x here, x into a minus 1, then minus 2. Let's factor 2 here into a minus 1 here. Then this is difference of 2 squares, so it will be a minus 1 into a plus 1. So this one is same thing as x minus 2 into a minus 1. Okay, let's write this very well, over a minus 1 into a plus 1. So this will cancel this. So the final answer equals to x minus 2 over a plus 1. So that will be the final answer there. So the next question here, the derivative of this is this. Find the value of a and the value of k. So if we differentiate this, okay, our answer should be equals to this. Okay, so let's differentiate this. So this will give us 14ax to the power of 6, then plus 3k x to the power of k minus 1. So the answer should be equals to 42x to the power of 6 plus 15x to the power of k minus 1. By comparison, you see that 42 is equals to 14a. So I can say 14a equals to 42. That implies that a is equals to 42 over 14 and a is equals to 3. So that means the value of a is equals to 3. Also, by comparison, so you see that 3k, here, this 3k is equals to 15. So that implies that k equals to 15 over 3 and k is equals to 5. So that means the value of k is equals to 5. So the last question 26. The diagram shows a parallelogram OPQT. The position vector of P is A and the position vector of T is B. K is on PQ, so that PK ratio KQ equals to 3:1. The lines OK and TQ are extended to meet at X. Find the position vector of X in terms of A and B. Give your answer in the simplest form. Okay, so the position vector of X is OX, and this is equals to OT plus TX. But we know that we know that TQ is equals to, we know that TX, this TX is equals to TQ add QX. So we can say that, okay, this one is 1, this one is 2. So we can put 2 in 1. So that means, so don't forget, you can put your arrow here, okay? Put the arrow there. So the same thing for this, and for this. So OX now be equals to OT, okay? So plus TQ plus QX. So put the arrow to show the direction, okay? So now we already have OT to be B. So OP is A. So that means TQ will be A. And then PQ will also be B. That's the whole of this, it will be B. Okay. So, but from this ratio, we were told that PQ ratio KQ equals to 3:1. So if PQ is B, then we know that the total ratio is 4. So it will be 1 out of 4 times B, then 3 out of 4 times B. So PQ will be 3 out of 4 times B. Then KQ will be equals to 1 out of 4 times B. Okay, and what we can now do, okay, is to before we can find the QX, we have two similar triangles. So triangle O, so we say triangle OT, let's say triangle OTX, okay, is similar to triangle KQX, okay, so they are similar, okay. So that means we can say QX over KQ equals to TX over OT. So that is the axiom we can use to get the value of QX. So we can write this better. So we can say that qx, okay, over kq will be equals to tx is already tq plus qs. So let's put it there, tq plus qx, that is from equation 2 over ot. So let's key in the values. So qx is what we want to find, qx over kq. If you scroll up, kq is 1 over 4b, and equals to tq is equals to a, tq equals to a, then add qx over b. Okay, so from here qs can cancel, sorry, what can cancel out? B can cancel out, b will cancel b, so we are left with qx over 1 out of 4 to be equals to a plus qx. Okay, so from here we can now cross multiply. Okay, so that will be, from here you have qx to be equals to 1 over 4 into a plus qx. So from here, what you need to do is to open the brackets. So if you expand the bracket, qs will be equals to a over 4 plus qx over 4. Then if you collect like times, so that means qx minus qx over 4 equals to a over 4. So that is what you have here. Okay, and if you do this, this will be 3qx over 4. That is when you subtract 1 over 4 from 1, this is what you have here, and equals to a over 4. So 4 will cancel 4. Then that means we are left with 3qx to be equals to a. So that implies that qx equals to a over 3. So now that we find the value of qx, then we can now substitute into the equation, I think 3 up here, into this equation, ox equals to this. Okay, that will give us the position vector of x. So we can say that ox equals to ot plus tq plus qx. Okay, so don't forget you can put the arrow here. Okay, so let's substitute the values. ot is equals to b plus tq is equals to a, and we just found qx to be a over 3. So if you solve these two, if you add these two together, you get b plus 3 times a, 3a, 3a plus 1, 4a over 3. And you can simplify this further by doing the same thing. 3 times b, 3b plus 4a over 3. And you can rearrange 4a plus 3b over 3. Okay, so that will be what you have there. Okay, and you still want to separate this, no troubles, like you want them to stand alone, maybe 4 over 3 a plus b. Okay, so there's no trouble, so you can write your answer like that. So we have 4a plus 3b everything over 3 as a single fraction. So this will be the end of this video. So if you are seeing this channel for the first time, please kindly subscribe by clicking the subscribe button, and if you are yet to subscribe, please kindly do the same thing. Also share, comment and like this video. So I value your comment and your observations. So in the next video, I'll be solving the components 2, 3 and 4, 3 respectively. Thanks.